we are doing number patterns with pictures. Now let's get started, okay? Let's get started. Okay, there I am with positive energy on you guys. Genius. Okay, so one thing to keep in mind, guys, we're not going to be working with a general formula for these. Okay, before I even show you this number pattern, let's go on this side and talk about what we're going to need to do here. So first thing is, there is no general formula. I know the general formula method was very easy for us last week, but not this time, okay? So there is no general formula. My handwriting is terrible. And my pen won't work. No general formula. So the things you need to look out for is, do I multiply anything? So multiplication. Do I have to add anything or subtract anything or divide anything? I should have said or divide. And the one that everyone always forgets is exponents. So your position can be in the base. So it's possible to say n squared or n to the power of 2 minus 1 or whatever, or it can be in the exponent. So it's possible to have 2n or 2n plus 1. Okay, so you need to look out for all these things as it relates to numbers with pictures, number patterns with pictures. But the one thing I suggest you do is you write down your position and you write down the value of the term. So guys, between Tn and n, tell me which one is the position and which one is the value of the term. I feel like we need to revise this first, otherwise everyone is just lost and doesn't know what's going on. Remind me, between n and Tn, hands are going up. I love this class. Everyone wants to speak to me. Melissa?
Ma'am, Tn, it's the term.
Oh, okay, or the value, yes. And what's n?
N, it is the term, no, that's the term value. No, the value of the term.
The value of the term is Tn.
Oh, the position of the term.
There we go. Thank you very much. Thank you very much for reminding us of that. So guys, every time I speak about position, we look at n. And when I speak of value of the term, we look at Tn. Now let's go on to our patterns with numbers. Okay, what's going on here? What's going on here? We have pattern 1, pattern 2, pattern 3, pattern 4. We have so nicely written down the positions for us. So now we have to figure out what Tn is. Okay, so in pattern 1, hello. Okay, there we go. Yeah, my screen is misbehaving, but it's fine. It's okay. So in number 1, we have how many matchsticks? 1, 2, 3. So N, T, N. We have number 1, 2, 3, number 4. So in 1, we have 1, 2, 3 matchsticks. Number 2, we have 1, 2, 3, 4, 5 matchsticks. 1, 2, 3, 4, 5, 6. Where? 1, 2, 3, 4, 5, 6, 7 matchsticks. And then in the last one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 matchsticks. What is going on over here? What have we over here? We add 2 matchsticks, but remember guys, when we spoke about Tn notation, we said we're looking at the relation between n, which is those dudes over there, and Tn, which is those ones over there. So you're correct. To go from one to the next, we are adding 2, but we want to know, how do I get from 1 to 3? So now we're going that way, right? That's what we're trying to do. You're correct that we're adding 2 from one to the next, but we want to know, how do I get from the position number, which is number 1, number 2, number 3, number 4 to Tn, which is 3, 5, 7, 9. Plus 2 as its odd numbers. Okay, that's true. Okay, guys, first things first is I said you must check for multiplication, addition, subtraction, exponents. If we're always adding 2, what kind of pattern is this? What kind of pattern is this? What type of pattern is this? Anyone? Linear pattern. Thank you, Bogang, which means it has what? What is this +2 that you guys were telling me? What do we call it? We had a special name for it. What is it? I'm not sure why I'm writing in red, and I'm not sure what's going on my screen, but there's a lot going on. Give me a few seconds to fix it. Okay. What is that called, guys? Remind me, that +2 that you all just told me about now, we have a special name for it. Constant difference. It's called our constant difference, which is D. What did we do with the constant difference? Actually, before we get there, give me the general formula for a linear sequence. Tn equals. What was the general formula for this? Let's go back to black. This red is not doing it for me. Tn equals. Linear means you are adding or subtracting the same thing, Kwezi. If you missed the previous lesson, please go watch it. It's going to be very, very important. Sharifa already has our formula. Multiply 2 and add 1. 2n plus 1. Thank you, Bogan. dn plus c. Guys, we need to listen to the instruction. I asked for the general formula, which was dn plus c. D was our constant difference. And C was what? Remind me what C was again. Remind me what C was. If D is our difference, then C is our, not the value. What do we call it? Or how do we find it? There has to be a way we can find it. People must know how we got to 1. Logical, okay, Emmanuel, I'm guessing you learned that at school, but I guess I understand what you mean. Logical number, or T0. Guys, it's the term that would have come before this. So if we had a term before this, which would be, we would call C, it would be 3 minus 2, which is 1. So then, our general formula has to be Tn equals Tn plus 1. Okay, so this was an easy one because we already did this stuff last week. Where did the hand go? I saw a hand go up and then it vanished, but it's okay. This was an easy one. This was a linear one. Bear in mind what I say. It will not always be linear. The trick is to look at the relationship between the position and the value. Okay. I feel like this was too easy for you guys, but it's okay. Let's go to others pattern. Non-linear is another story. Exactly, Havana. But I had to be nice. I had to be nice. You know, I'm the nicest teacher you can ever meet, guys. N. So 1, 2, 3, 4. Let us count in the first position. How many dots do we have? How many dots do we have? Okay, I'm guessing my network is still getting there. But I'm guessing we can all see that we have 3 dots in the first position. Okay, second position. How many dots do we have? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 6, 8. When they say 6, it's definitely not 6, my dear. There's 1, 3, 6, 7, 8. It's definitely not 6. Okay. And then in the third position, how many do we have? Yo, I see 7, 8. What's going on? Come on, guys. Let's count together. In the third one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And in the fourth pattern, how many do we have in the fourth pattern? Counted wrong. It's okay. I know eyes go a little bit squint. I'm also like, wait, what? is green. 24. Okay, this is a very nice pattern. This is a very beautiful pattern. 20, nope. And then my pen is like, I'm not going to cooperate. I don't care about your beautiful pattern. 24. Does anyone see a pattern here? Does anyone see a pattern? 24. So there's this favorite pattern that I always give to you guys. There's this favorite pattern that I always give you guys. Check these numbers out, guys. There's something very special about TN. Do we see anything special about TN? We do add odd numbers, and we also saw that in the other pattern that we have done. We also used to see that in the other pattern. These numbers, do they look vaguely familiar? Let me help you in this way, guys. If I had a dot there, if there wasn't a dot missing, what shape would I have here? It's not prime numbers, guys. It's remembering all my favorite patterns. It's not prime numbers, though. If I had a dot there and it was not missing, what type of shape would I have here? Oguhle? Okay, Oguhle vanished. A square. I wonder if anyone is seeing anything here. Oguhle is back again. Hi, Oguhle. Hello. Okay. A cube. It is not a cube. Remember, cube is 3D. And if I had one there, I would also have a square, right? Because it's the same amount of dots on each side. 1, 2, 3, 1, 2, 3. And if I added one there, I would also have a square. 1, 2, 3, 4. 1, 2, 3, 4. What is going on here, guys? But I took away 1, didn't I? So it's square numbers. We know it's some sort of square numbers, but I am subtracting 1. Don't guess, guys. Look carefully. They're square numbers, but I am subtracting 1. But no, it's not cube root, Avril. It's not cube root. It's square numbers, right? So if I had not taken away 1, let's say I didn't take away 1 there, right? We would have what? 4, 9, 16. Aren't those perfect squares? 25. Do we see that, guys? Aren't those perfect squares? They are. They are, yes, Falisa. See, I told you this one was a little bit challenging, but I know you guys can do it. 2 to the power of 2 minus 1. Sharifa is this close. This close to getting it. What are square numbers? Boniwe, square numbers are those you get when you multiply a number by itself. So if I say 1 times 1, that is the same as 1 squared, which will be 1. 2 times 2 is 2 squared, which is 4. 3 times 3 is 3 squared, which is 9. You get the point, Boniwe. So those are square numbers. But I'm minusing 1 from each of them, right, guys? I'm minusing 1 from each of them. So if I said to you, the rule was n squared minus 1, would I be correct? Would I be correct? Check there. Would I be correct? Power of 3, no, Havana, excuse me. Because 1 cubed is 1 and 2 cubed is 8. So that wouldn't work. Check carefully, guys. If I said the rule was n squared minus 1, because we said it's square numbers, but I'm subtracting 1, would I be correct? Did we check? Did we check, guys? I feel like we didn't check. We are not checking. We're just saying yes. Who said no? The person who said no, raise your hand up and tell me why. Koenga, tell me why. Tell me why that would be incorrect. This thing is irritating.
That'll
I
be
don't understand.
incorrect because what's this? Because if you said 1 to the power 2, it will give you it'll give you 2 minus 1, and then I'll give you 1. It wouldn't give you 3.
Okay, so what's missing here? Aren't the square numbers off by 1? Because 2 squared minus 1 would give me 4 minus 1, which is 3. No, you didn't. No, you didn't. Because if we checked follow, let's check this. 1, which is position 1 squared, minus 1 would give me 1 squared is 1, minus 1 is 0. Is there a 0 in the first position? No. 2 squared minus 1 is 4, minus 1 is 3. Is there a 3? No. So they are off by 1. Do we see that? So we didn't check. We didn't check. What do we first have to do to n before we square it? If they're all off by 1 position, what do we first have to do to n to square it? Add 1. Thank you, Sharifa. We have to add 1. Oh, this was nice and challenging for us. Let me take off these dots. Let me confuse us. So you have to say n plus 1, then square it, then subtract 1. This was a horrible one, I admit it, but I love it. Do we see that, guys? Do we see why we have to do that? Everyone else in the chat, tell me something. Sharifa has figured this out. TN, no, this is the incorrect one. Everyone in the chat, let's hear from you. Yes, Tanga, you were so close. Pamela says yes. Zoom user, raise your hand and let's hear where I lost you. Raise your hand, Zoom user. Follow. Hi, follow. Hello.
Hello, ma'am.
Yes, let's hear what you have to say.
I'm a bit confused because if we were to square the n because we distribute, it would give us 1 square. It would give us 1 squared plus 1 squared, which would be
follow. When do we distribute our exponents? Let's go back to laws of exponents.
In the law 4.
But what's happening in law 4? The condition is you have to be what? Look at you. What is the sign?
It's a plus. Oh, it's a multiply.
Thank you. Do you see why you're not going to distribute the square?
Oh, yes, I see now.
So you first have to add. It forces you to first add and then square. Do you see, follow? So in the first one, it would have to be like 1 plus 1. And 1 plus 1 is 2 squared minus 1, which is 4 minus 1, which is 3. You see?
3.
So remember,
yes, ma'am.
The laws of exponents say you have to be multiplied.
Yes, ma'am.
Okay.
Yes. Yes.
Okay.
Thank you, ma'am. Thank you, ma'am.
You're welcome. Abisha, please raise your hand. There we go. Your hand is raised. Hi, Abisha. Hello. Abisha is very quiet and not unmuting. Okay, Abisha, I don't know if it's my connection or what's going on, but you can type your question in the chat and I will try to.
Can you hear me now?
There we go. Yes, I can.
Ma'am, I don't understand how we got the TN.
Okay, Abisha, check here now. So remember I said you have to look out for patterns that have exponents multiplied, added, everything, right?
Yes, ma'am.
So we wrote our positions and values down. Let's redo it on the side here. So N and Tn. So in position 1, we have 3 dots, right? In position 2, we have 8, 3, we have 15, and 4, we have 24. So Avisha, let's talk about TNs. Do we see these numbers?
Yes, ma'am.
They are all very, very close to square numbers, but they are off by 1. Do you see that?
Yes, ma'am.
You have your list of square numbers in front of you.
This is square numbers, yes, ma'am.
Okay, there I wrote them quickly for you on the side. 16. So we don't have this one, the 1. But look at that. 4 is only 1 more than 3. Do you see? 9 is only 1 more than 8. 16 is only 1 more than 15. So it's clear that we are subtracting 1 from square numbers. Do you see that?
Yes, ma'am.
So far you're with me.
Yes, ma'am.
So we know that we're going to take something, square it, and then we have to minus 1. But, Abisha, I said, if I say to you, n squared minus 1, would it be correct? No. Because if I put a 1 there where you have n, that would give me 1 squared minus 1. What's 1 squared, Abisha?
1 squared. 1 squared is 1.
It's 1. And if you subtracted 1, you get 0. That's not what's in the first term. Do you see that?
Yes, ma'am.
But if I say, let's say I tested with 2 squared. 2 squared minus 1, this would give me 4 minus 1, which is 3. That is our first term. You see?
Yes, ma'am, I understand it.
So we would have to first take the position and move it up by 1 in order for your square numbers to align. Do you see that? So you have to say position 1, first add 1, which will give you a 2, then you can square and minus 1.
I understand now, ma'am.
Are you sure?
Yes, ma'am.
Beautiful. Okay, guys, that was a really challenging one, wasn't it? Oh, I'm even sweating. I hope we are sort of got it. So remember, guys, and we're going to do more examples. Yes, I have plenty of more examples like this. But remember, guys, I'm trying to show you that you need to look out for everything. You need to look at your numbers. Do they look familiar? Are they one off from square numbers, cube numbers, prime numbers? Look at those patterns, okay? Just want you guys to learn to recognize those difficult patterns, okay? Let's see what I have next. Okay, this one is way too easy for you guys. So I'm just gonna go right past it and we're gonna stop here. And on this one, the first thing I want to highlight is we are looking at the number of shapes, okay? We're not looking at the number of sides. Do not count the number of sides. We are counting the number of shapes. Okay, let me move this up. So in n equals 1, we have 1 shape. That's what I'm talking about. In n equals 2, we have 2 shapes. Okay, there we go. So we have n and we have tn. 1, 2, 3. So in the first one, we have 1 shape. In the second one, we have 2. Third one, we have 1, 2, 3, 4. What is happening here? Remember, we're looking for the relationship between the n and the tn, going down. You can check going from side to side just to see if it's a linear pattern. Okay, NB. To see if it's a linear pattern, you can say, okay, from there to there, I added 1. And then I added 2. Is it a linear pattern? No, because we're not adding the same thing over and over again. You see, so now you know you're gonna have to think. You're gonna have to dig into your multiplications. You're gonna have to dig into your exponents and all of that. We multiply by 2. When you're done, can you please go back? I will. Then all the lessons stay and I'll go back for everyone to copy the screenshots. Excuse me. Okay. Let's check. Times 2, guys. Okay, if I said, I'm going to remind you again. Remember, Tammy, we're not working with constant ratios. You're not supposed to be using that in grade 9. Your teachers are robbing you. We do not use TN. But yes, there is a constant ratio of 2. But how do we get from there to the bottom, which is there? How do we get from there to there? And Tammy, if you know that the constant ratio is 2, what do we do with it? How do I get from 1 to 1, from 2 to 2? Sounds easy so far, but then I go from 3 to 4. And it's like, excuse me? What have we here? Not supposed to Bontle, it's a FET method. Zoom user says +1. You don't add 1 going from 1. I want all those people who are talking about constant ratios to raise their hand. Mamelo says n times 2. Mamelo, do you mean n squared or do you literally just mean n times 2? We are doubling, okay? Guys, remember, I'm not looking for the relationship from 1 to 2 to 4. I'm looking for the relationship from 1 to 1, 2 to 2, n to the power of 1. Not quite. Remember, guys, n can be in the base or in the exponent. That is a very big clue with this one. There's a very big clue with this one. And my handwriting was horrible and it didn't match the image. Exponent. N can be in the base and it can be in the exponent. So if you have n in the base, it's fine. We can check. If you guys want to check, n to the power of 1, that would be 1 to the power of 1, which is 1. So it works for the first one. N to the power of 2 would be, n to the power of 1, 2 to the power of 1 would be 2. It works. But look what happens when we get to 3. 3. That's not a 3. So that can't be a formula. That can't be a formula, guys. So we've checked. Keisha, I'm not going to teach you that now. When you get to grade 10, you get to do all those complicated methods. You get to do all those complicated methods. Okay? So let's try and put n in the exponent. So if I have 1 to the power of n, 1 to the power of 1 is 1, it works. Okay? 1 to the power of, I'm already giving you a very big clue right now. 1 to the power, n to the power of 2, no. 1 to the power of 2 is still 1. Remember, Sharifa, anything? 1 to the power of anything is still 1. So that's not going to work. That's not going to work. How about we test with 2? 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. That's not going to work. That's not going to work. Anyone have an idea? 1 to the power of 2, no Zoom user. Zoom user, your name is still Zoom user. It's bothering you. Guys, okay, I want to check something. Let's do this. Number 4, number 5, number 6. Tell me, if I had term 4, what would be the value of the term? Oh, Fulu has a answer for us. But we need to all get there. Timoloho. Hi, Timoloho.
Hi, ma'am.
You have a question?
So, ma'am, when I tried it, I said 2 to the exponent 0 gave me 1. And then when I said 2 to the exponent of 1, it gave me 2. So, ma'am, when I said 2 to the exponent, how did I say 3? I don't know how. I didn't say 2 to the exponent 3, but I don't know how did I get there, ma'am. So that's my problem.
You are on something. Don't run away, ne?
Yes, ma'am.
Don't run away. I want you to tell me, Simoloho, If I had a term number 4, what would be the value of that term?
Term number for 4.
You said we are doubling, right? You said from
Yes,
root,
ma'am.
then you said times 2. Times
Yes,
2.
ma'am.
So if I went from 4 to there, times 2, what would that be?
Ma'am, 4 to what?
4 to the next term. What's 4 times 2?
8.
8. So the next term would be 8, right?
Yes, ma'am.
Which corresponds with 2 to the power of 3, doesn't it?
Yes, ma'am.
You see that you are onto something, Simo?
Yes, ma'am.
So let's continue. The only problem now, Simulcon, is this is off. That's a 0, but our first term is always T1.
Yes, ma'am.
See that?
Yes.
That's a 1, but that's on position 2. That's a 2, but that's on position 3. What's going on there with the exponents on the position number? What do we have to do to the position number? See there, they're helping you in the chat. What do we have to do in the position number to fix it and make it fit our formula? Let me use a different highlighter and show you again. Palisa says subtract. Okay. What are we subtracting, Palisa? How Timolofo, she really started it out off so nicely for us. So you said the first one, Timolofo, is 2 to the power of 0, I guess, right?
Yes, ma'am.
But that was in position 1. So what did we
Yes,
do to get from a 1 to a 0? What did we have to do?
ma'am, to get from a 1 to a 0, I think you'd minus 1.
Minus 1. So your exponent is the position minus 1. Do you see that?
Yes, ma'am.
Because the first one, you said, if it's T1, it's going to be 2 to the power of 1 minus 1, which is 2 to the power of 0, which is 1. And that is indeed our first term. You see?
Yes, ma'am.
Well done, Simulfo. You were almost there. You were right there. Okay, guys, I see you in the chat. We were figuring this out before we even spoke about it. So it's 2 to the power of n minus 1. So yes, guys, our exponents, I think sometimes the problem is there's too few of these. See, as soon as I wrote the next one, everyone started seeing that there's something going on here, right? So now, in this case, our exponent is the position, but you have to subtract 1. Oh, that was a difficult. Who's in the mood for a brain break? You guys are brilliant, man. I love it. Simoloho was almost there. Who's in the mood for a brain break? Let's see. Let's do our brain break. I'm pretty sure I had another pattern after this, but it's fine. I'll forgive you. Yo, guys, I had so many more patterns after this. I nearly killed you guys. Woo! Okay, there's the first one for our brain break. What do other people use more, even though it belongs to you? Manuel? Manuel has seen this one before. I can feel it in my blood.
I haven't, but I think it's your name.
It is, Emmanuel.
No, on God, I haven't seen this question before.
Okay. Thank you, Emmanuel.
No problem.
Sia? Is Sia there?
Yes, ma'am.
You ready, Sia?
Mine would be my name.
It is, but I'm giving you a different one.
Okay.
Felix's father had 3 sons, and their names were Snap, Crackle, and
Bam.
Nope.
Pop.
Nope. Read it again. Felix's father. So the 3rd son has to be who?
Felix.
Aha, caught you guys out of that one. And now I do see that you have Rice Krispies for breakfast. What a way to expose. Hi, Abisha.
Hi, ma'am.
You ready?
Yes, ma'am.
Let's see what you got. What has keys but cannot unlock a thing?
A lock.
Mm-mm.
A piano.
Yeah. A piano has a bunch of keys, but you can't use it to unlock anything. That was a good one. That was a good one. Hello. I'm hoping your name is Hello. I'm at this point.
Hi, ma'am.
There you go. What has teeth but cannot eat?
What has teeth but cannot eat? A comb.
Yes. Hello, you've seen this one before. You guys are cheating me. I see you, Hello. That's fine. But anyway, please mute yourself, Hello.
Oh, sorry.
Hi, Boniwe. Boniwe. Fork. I don't know if fork qualifies, guys. You guys are complicating my life. It's a comb. See, Tanda. Remember what we said about the rules in the chat? I saw that. Boniwe, you there? Boniwe is not answering. Hello. Boniwe, I'm gonna have to move on to Tepa. I know, Nelson, now they are confusing me.
Hello.
Hello.
Danko is thank you. Now there's 50 hellos. I don't know what's going on. Hi, Boniwe. Nope, never mind. You, there's a lot going on. Hi, Tapang. There we go.
Hi.
You ready?
Yes.
Let's see. Would you rather be covered in fur or covered in scales?
I think I'd be covered in fur.
Guys, I don't get it. Gonga is thinking like me. Guys, why would you want to be covered in fur? Imagine having hair everywhere. It gets tangled. You have to comb it. You have to cut it. You have to.
But scales are weird.
And Nicole has a point. You'll be a mermaid.
I guess so.
What if it gets cold? Manuel, I guarantee if you have scales, you can survive the cold. You can survive. I'll be soft and fluffy. You guys are a lot for me to take in. You guys are a lot for me to take in. I'm gonna move on with my life. Londe, are you there? I'll be a mermaid, guys. I'll be a mermaid. Have you ever seen mermaids get cold? Come on. Londe, are you there? Sharifa says, I'll be my cat.
Yes, ma'am.
You ready?
Hello, ma'am. Yes, ma'am.
There we go. Would you rather always have to hop around on one foot or always have to squat?
1 foot, ma'am.
Lwandle must go to the gym. Why is Lwandle choosing hop on one foot? Why would you rather hop? I see a lot of people say squat.
Because, ma'am,
You
that's
guys-
easier.
It is, that's true. I would also always hop on one foot. I'm not gonna lie. Not going to lie to you guys. And that would be the end of our brain break. I hope our brains have taken a break. And I hope you guys change your mind about the fur. That's all I have to say. Okay. Now, are we ready? Are we ready? Everyone have a stretch. Oh, I need it. Hope we're ready. We are going into our next set of patterns. And this time I wrote go team. Do you see? I didn't write the evil laugh. So it means it's gonna go well. And I'm gonna skip that one because it's too easy. And that one. Okay, we can try this one. We can try this one. What have we over here? Does this look like the pattern we just did? Let's see. 1, 2, 3, 4. No, it doesn't. Let's see, guys. Manual is ready. I can see Manuel stretching me. Yeah. Let's see, guys. Let's try to find Tn for this pattern. It triples. Ooh. Are you sure? N and T. In this case, we have 1, 2, 3, 4 N's. And then Tn for the first one is 1. The second one is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That I can't properly. 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What have we here, guys? This one is going to remind you guys to follow my instructions. I said you must first check for something. Let's see if people are going to remember to check. Oh, you did. So if we're adding 3 every time, what type of pattern do we have here? Oh, you guys are on fire. Plus 3, plus 3, plus 3. What type of pattern do we have? D equals minus. It's not negative 3. What type of pattern? Linear. That means we can go right ahead and use our general formula. Now, guys, use the general formula. I'm giving you 2 minutes and tell me what your general formula is at the end. 2 minutes. I'm timing this. Okay, I'm timing this in 10 seconds because otherwise it's just a middle of nowhere. There we go. 2 minutes have started. Use the formula, substitute. Tell me what type of pattern we have here. You must find Tn Balesa. Here we have established that this is a linear pattern, right? Because it always has a constant difference. We are adding 3. We are adding 3. We are adding 3. So this must be a linear pattern. Therefore, we're going to use Tn equals Dn plus C to find our general formula. This is what we're using over here. Tammy has an answer for me. Whoop, whoop, whoop. That's what we're using. 3n plus 1, 3n minus 2. Ooh. Let's see. I hope you guys checked using the other terms. 3n minus 2, 1n plus 3. Ooh, there's a lot going on. Okay, more people are saying 3n minus 2. My eyes are going blurry. Guys, please remind me to find my losses. 10 minus 2, 3n minus 2. Okay, looks like we have a consensus. There's about 2 minutes up. No, it's not. There's about 30 seconds left. There's about 30 seconds left. Everyone else, tell me what your answer is. If your answer is already in the chat, that's fine. Put it in anyway. So I want to see it. I know that you guys are working and participating. 3n plus 1. Oh, there's so much confliction happening over here. Okay. 5, 4, 3, 2, 1. Okay, let us see. So we've already established that our D is 3, positive 3. So if there was a term before this, C or T0, that term would be 1 minus 3, which is indeed negative 2. So therefore, Tn is 3n minus 2. Beautiful, guys. Beautiful. Well done to those who got it right. If you didn't get it right, let me know if you see your mistake. For those who are saying 3n plus 2, remember, this is plus negative 2. But then when I have this situation over here with integers, positive and a negative, and this is going to give you Tn equals 3n minus 2. Then you check it. I said you must check it. T1 is equal to 3 times 1 minus 2, which is 3 minus 2, which is indeed 1. Beautiful. Let's check it with T4. T4 is 3 times 4 minus 2, which is 12. 14 minus 2, no, 12. Oh my gosh, guys, I can't multiply anymore. 4, 8, 12 minus 2, which is equal to, and my pen is like, I'm not cooperating. 10, and it is indeed 10. Beautiful, guys. Yeah, remember to check your formula, guys. Check your formula. We all make mistakes, so please check your formula when you are done. Let's see what we have over here. Let's see what we have over here. Let's move this out the way. I think we can fit in 2 more patterns, so I'm going to fit it in 2 more patterns. You guys can do it. I know you can. Sorry, I was just moving those out the way. And if my laptop can unfreeze and cooperate with me, there you go. There you go. Giving you again, this time I'm going to give you 3 minutes to find TN for me. 3 minutes. One, two, three, four, five, six, seven, 8, 9, 10. Back to where, my darling. 1, 2, 3, 4, 6, 7, 8, 10, 11, 12, 13. Alyssa? Tammy has an answer for me. Tn equals 5n plus 1. How's everyone else doing? I'm starting to think 3 minutes was way too long for you guys, but it's fine. I'll stick to my word. Manuel has an answer for me. Which one is that, Melissa? Just stay on after the thingy and I'll scroll up for you after this, okay? Bokan says TN. Very loud. Remember to use a small letter N. Be careful, guys. Notation is very important. Okay, we always use a small letter N. 5n plus 1, 5n plus 1. Guys, you could have used the formula, but honestly, this one, you could have seen it. Right? 5 times 1 is 5, plus 1 is 6. This was me giving you another brain break, actually, now that I think about it. Right, guys? Whichever way you did this, you could have done this by just observing, guys. It's very much possible. But if you could have seen that we were doing a linear number pattern, you'd have seen that we are adding 5. Okay, so we go from 6 to 11, that is plus 5, which means plus 5 has to be a constant difference. If there was a term before this, it would have been, C would have been 6 minus 5, which is 1. And now we're going to substitute dn plus c, which is 5n plus c, which was 1. Brilliant. Tato is definitely not 5n minus 4. Be careful. Check your answer again. Tato, if you're still confused, raise your hand so we can talk about it. What have we at the bottom? Let us do this one. So last one, guys. After this, we're gonna head off and go and relax. Let's do this one. Fastest fingers first. Whoever has the answer first, post it in the chat and we're gonna check it. 1, 2, 3. So this is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I need to stop counting out loud. I'm just telling you guys. Let's see. Does anyone have an answer? I see a lot of messages in the chat. Ma'am, just in case whenever we have a constants, will always be limited. Thank you, Melissa, for clarifying. Yes, it will. 7n plus 5. Okay, Tammy has an answer for us. 7n plus 5. Let's check. Plus 7 plus 7. We have a linear sequence. Again, Tn equals Tn plus C 7n. And if you multiply 7 by 1, you would have to add 5. Beautiful. We are done, guys. We are done. Thank you so much for being such beautiful sport. Let me know in the chat if you want me to scroll somewhere so you can take a screenshot. Otherwise, you may go. Thank you for being such fabulous people.
Palace, I want to take a screenshot.
Okay, let me first explain to Awugile. Where did we get the 5? Okay, there's 2 ways to do it. You either say, if we had a term before the first one, what would it be? So Awugile, if we're adding 7 and we're going backwards, we would have to subtract 7. So we would have to start from 12 and you subtract 7 and that would have given you 5. Alternatively, you check from here. Okay, we said it's 7n, which would mean 7 times 1 for the first one. 7 times 1 is 7, but that's not what we want. We want a 12. That's why I added 5 to get to where I wanted. Okay. To the third last question. Oh my goodness. Will we get a mark?
The previous question as well.
Okay. I'll go there just now. Emmanuel says, would we get a mark for writing TN in my class? You would. Okay, let's do this one. You're welcome, Abugile. You're welcome, guys. Bye. Have an incredible evening. Please answer the poll. You guys have 10 seconds to take a screenshot of this, and then I'm moving on to the next one. You are welcome, Inga. Have an incredible evening, guys. Stay awesome.